Okay, so today we are going to discuss about the network design, the different types of zones, and the VR means virtual router concepts in the Palo Alto device. Okay, so you can see here there are first point here, that is management versus data plane. So there are two plane available in this Palo Alto device: management plane and the data plane. So management plane we already configured. So what is management plane? This is our management plane. Let me just make it. Okay. Now this is our management plane. So here we already assign IP address to the management port, right? This one, 192.168.1.46, and its subnet is /24, right? So, and we already assigned one default gateway to this management port also. So this is our management port. You can see here in the diagram also. So we already configured this thing. So what management port will do? So with using this management port, you will manage your Palo Alto device, and as well as we also assign the default gateway and DNS servers to this management IP. So by using the default gateway and DNS server, the management IP, this IP will communicate with directly to the ISP through your router, like this way, through your router.
Anish, there is some disturbance. Can you just tell again? I didn't get.
Now it's fine. Now, using this management IP address, what we can do, we can manage our Palo Alto device, and as well as we also assign the default gateway IP address and the DNS server. So using that credentials, the management IP address, this IP address will directly communicate with your ISP through your router. Okay, and from there you will get the updates on this Palo Alto device. You will check the license status. You can access this device. Sorry. You can access this device from outside of this network. Okay, so this is our management plane. Now next is our data plane. So what is data plane? Okay, so you can see here there is one PC out here. This is my PC. Okay, and this PC is connected to 1/2 interface, right? Right, guys?
Yes, Anish.
Okay. Now,
Yes.
what is the network address for this 1/2 adapter?
On 10 dot
10 dot
0.
2.2.0.
2.2. How? I am talking about this one.
10.1.1.0.
This one.
10.1.
This is the network address for this.
Yeah, 10.1.1.0.
Yes, this is the network address for this 1/2 network interface. So you can see here, this is my internal network. This is my internal network. This is my user. Suppose there's one user here. There's one user here. Okay, and it is connected right now, accessing this system. So if this user wants to access some resources from the internet, okay, so how the packet goes? So it will go to this 1/2 interface, then it will go to the 1/1, and from here it will go to the ISP. And the same way, the ISP respond to the 1/1, then 1/1 respond to the 1/2, and this is to the user here. Okay, so this is called a data plane, the user interface, we can say. The traffic which is used by the internal users, that is, we include this one into data plane. And also, suppose there is one outside, there is one user here. We can say Matt. There is one user Matt outside on my ISP, and he want to access, the Matt user wants to access this server, DMZ server. This is my DMZ. This is my DMZ server, and this is my web server. Okay, so the user Matt, which is located on the ISP, and he wants to access my web server. So how the packet process here? Let me just change the color here first. Now, so the Mac user, so he will directly connect to the 1// interface. Then from 1// interface, it will go to the 1/3 and to the web server. And the same version, it will respond. The web server respond to the 1/3, then again it will go to the 1/1 and to the Mac user. So the traffic which goes to incoming from internal network to the ISP level, and from our ISP to internal network, and also from outside ISP level to the DMZ network, and from DMZ to ISP. So this whole traffic that is called data plan. This whole traffic that is called what? Data plan. Understood?
So Anish,
Yes.
yeah, what kind of traffic does management interface send to ISP?
Okay, so management interface, we use this management to manage this Palo Alto device.
Okay, so initially it requests the Palo Alto means the connection between the Palo Alto device and ISP is made by management interface, right?
Right.
That's it.
But only for the access the Palo Alto device, and to have like each and every system have some updates, right? Software update
Okay.
or any packages. So the Palo Alto device will take all these updates through management from the Palo
Okay,
Alto
so
network device.
so for example, if there are more than one ISP, like 10 or 20 ISPs,
Mm-hmm.
for example, so management keeps all the data of those ISPs in it, or?
Simple thing. Here you just need to remember one thing. The management interface in the Palo Alto device, it will use to manage the Palo Alto device, and also we assign the default gateway and DNS server to this management interface, right? So that using the
Mhm.
default gateway and DNS server, the management interface, this IP address, whatever IP address we assign to the management interface, so that IP address, with the help of this IP address, and the Palo Alto device will directly communicate with the Palo Alto website to get updates.
Okay, okay,
Okay, so that is the use of the management interface.
okay.
Okay, and the license is bound to this IP address only in the Palo Alto, the management.
Okay.
So basically you say it forms the connection between Palo Alto and ISP, right?
Yeah, ISP we are not directly connected to the ISP. We can see here that there is one router here. You can see this is one router, right?
Yeah, yeah.
Okay. So this router is the mediator between the ISP and the this management. So the traffic goes to the router, and the router is connected to the ISP. So like same way here.
Okay.
Are you getting my point, guys? All of you?
Yeah, yeah. What if there are multiple ISPs?
So it
They
will
are all
communicate.
connected to
Yes, they
the
both
same
also.
router, or they have their own routers?
This is the I put router here. Suppose if you have any layer 3 switches out there, and you connect your Palo Alto device to layer 3 switch, so it will directly first communicate to the layer 3 switch, then it will communicate to the router, and then it will communicate to the ISP.
Okay.
That depends
Okay.
upon your existing network, on which device you
Got
connect
it.
your firewall device.
Yeah, yeah. Got it. Got it.
Okay. So understood this both these planes, the data plane and the management plane, guys.
Yes, Anish.
Everyone,
Yes, Anish.
this is the important thing, guys.
Yes, yes, Anish.
Okay,
Yes,
so
Anish.
Yeah. Yes, Anish.
good. Let me choose one more color. Okay. Now, so in this data plane, okay, so how many interfaces are included into data plane? So one slash this one. Let me choose another color. The dark one. Clear one. The 1/2, 1/3, and 1/1. These three interfaces are included into our data plan. 1/1 and 1/2 and 1/3. These three included into data plan. These three interface, and this management interface included into management plane. Got it now, everyone?
Yes, Anish.
Okay. Now, what is our next point? Okay. Now, next point is, just a minute.
Sorry?
How many
Sorry,
network
Anish?
options we have?
I
Name them.
HA, tap mode,
HAN tap.
layer 2, layer 3, and the V-wire.
V-wire.
And tap.
Tap. Okay, then one more.
Yes.
Layer 3.
Layer 3, layer 2, V-wire, tap, and HA.
HA and tap.
Right.
And tap.
Yes. Now, if anyone asks you a question, what is layer 2 interface development in Palo Alto? Are you able to answer this?
Yeah.
And guys, today I'm sending you one kind of Palo Alto guide, which I have one PDF file with me. So that file will help you out to understand the concept better.
Okay.
Okay. So this is the 3 things. Okay, now what is the next point? That is data plane routing tables. Data plane routing tables. Now guys, tell me what is routing table? What is routing table?
Table will store the information about packet.
So routing table
basically
Next hop information.
Yeah.
The source and destination address are included in the
If interview will ask you the question, what is routing table? How are you going to answer this question?
Layer 3 table that stores the IP addresses where the packets need to be guided by routers.
Okay. So in short, routing table has the information of all the paths, how the
all the routes.
Yes, all the routes of your network, right? Of the router, not the network. We can say particular router. Okay, so here we have one more, that is a data plane routing table. So in this checkpoint, okay, we have one more concept that is called VR, virtual router. So in Palo Alto, we have one more concept called VR, virtual router. So we can add a virtual router into a Palo Alto device. We can add a virtual router into a Palo Alto device. So first, understand one thing, the data plane routing table. Okay, now you already saying that we already assigned one default gateway, right, to this management.
Yeah.
Right, guys?
Yes.
Okay, but that applies to the management. So we have the data plane also. That is 1/1, 1/2, and 1/3, right?
1/1.
So yes, so we need to add one more routing table, one more default gateway for this data plane also. The default route which we apply, that will work only to manager interface. It won't work to this data plane interface. So we need to choose one default route for this data plane interfaces. That is 1/1, 1/2, and 1/3. So remember one thing, guys. In this Palo Alto device, what is the important? Routing is important. In the Palo Alto device, the routing is the most important thing. If you want to configure any Palo Alto device, you need to know about the routings. And you can also add one virtual router into your Palo Alto device. And into the virtual router, you can configure OSPF, BGP, RIP, everything, each and every protocol which you configure on physical router. Okay, so to launch this Palo Alto device, to configure it, you need to know about the routing. So that is, the routing is most important in this Palo Alto. Okay, let me just explain you one more thing. That is, let me just remove all this thing. Okay, now suppose I have one router here. Okay, now this router is connected to 4 interfaces. 1, 2, 3, and 4. Okay, so now this one we can say the topology for first interface, that is 10.1. Then this one we called as 10.2, the network address. Then we can say 10.3, and this is at the 10.4. Okay, now guys, tell me in this diagram how many routing tables we have.
One
How
routing
many?
table.
one routing table.
Was
Sure.
Yeah, Anish.
yes.
And all these four interfaces are considered
Yeah.
on different protocols then, different routing protocols then.
Sorry, can you repeat that?
Now, suppose this is one network, one interface, right? And it has a network that is 10.1, right? So it also has their own routing table for this only interface?
No.
No?
No.
So you are asking, would there be a routing table for just one interface?
Sorry, I'm not getting your, can you please come again?
No, you are asking, would there be a routing table for just one interface?
Yes, that we can find, yes, that we can find. Have everyone heard the word called global routing table? Global routing table?
No.
No. So that's why. Okay, so in this router, this is a router. So in this router, we have four interfaces, and the four interfaces have their own topologies, their own networks. Okay, so this first interface has their own routing table. The second also has their own routing table. Third also has their own routing table, and the fourth also has their own routing table. Because this all the four interfaces have their different networks. They are not in the same network, guys. But you're getting my point. If you have the same network, then you will find all the things in a one single routing table. But this all the four interfaces have four different networks. Okay, and you will find this information in any of the router and global properties of the router, global routing table. Okay, now suppose if you want to bifurcate this thing, suppose if you create two part, if you create the routing table in two parts. So let we can say this 10.1 and 10.2, it has the routing table A. So the interfaces topologies route information, it also stores in the routing table A. So routing table A has the route information of 10.1 network and 10.2 network, and you have another routing table, this one for 10.3 and 10.4, that we can say routing table B. Okay, so this is why I'm talking about the physical router. So what we are doing in the physical router, so there's all these things we can do in the virtual router, VR, virtual router, in the virtual router. So in the Palo Alto device, we are going to add virtual router. So in the Palo Alto, there is the one default virtual router is there, and we are going to add the virtual router into Palo Alto device in the practical session. There is VR1, virtual router 1. Okay, so these three interfaces. Now let me just show you this. These three interfaces, that is 1.1, 1.2, and 1.3. These three interfaces, okay, these three interfaces are connected with virtual router VR1. They are connected with VR1 virtual router. Okay, you understood this thing practically when we do the practical over there. Okay, so we have the virtual router concept in our Palo Alto. Okay, so after this we are going to see the practical, what we are explaining this thing, what we are doing right now, the theory one, we are doing this practical. So we are going to add one virtual router into this practical session, and the virtual router, all these three interfaces, 1/1, 1/2, and 1/3, all these are connected with a virtual router. Okay, now understood this virtual router.
Yes.
Suppose if you have more than three, suppose if you want to add more, virtual router again number 2, VR2, and if you have more than 1, 2, 3, the 1/1, 1/2, and 1/3. Okay, these three interfaces are connected with virtual router 1, and you have one more router, virtual router 2, and you have two more interfaces, that is called 1/4 and 1/5. Okay, so this 1/4 and 1/5 also you can also connect these two interfaces to virtual router 2. So how many routers we have? VR1 and VR2. So we have two routers into Palo Alto. And this two router has this two router, the 1/1, 1/2, and 1/3 is connected with the one router, virtual router 1, and 1/4 and 1/5 is connected virtual router 2. So we can say we have two different routing protocols into here in the Palo Alto. Okay, now to understood this thing, yes.
Sorry to interrupt, but could you like tell me what exactly would be the use of using a virtual router? Like I did not understand.
Simple
much
thing.
about it.
Simple thing. Now, are you using a router in your home?
Yeah.
Okay. So if you configure a router like this way, you won't access any kind of telnet services. So anyone who is connected to your router, they are not able to access telnet, right? Because you block that from your router only. Right. So in the same thing, this applies to in Palo Alto device. So we have three interfaces, 1/1, 1/2, and 1/3. So these three interfaces are connected with your virtual router.
Okay.
Okay. So whatever routing protocols or route we define in virtual router, that's all these three applies to these three interfaces.
Okay.
Now got it?
Yeah. So it's just acting like another router. That's all.
Yes. Yes. Inside of a Palo Alto.
Okay. Okay, Nisha. Got it.
Okay. So have you understood this? The data plan, routing tables. This
Yes,
is about
sir.
the virtual router concept.
Yes.
Okay.
Yeah.
Now next thing that is our zones. Zones. Okay. So uh, how many network interfaces we have here in this diagram?
4.
Which are they?
So
The data plane and
Management.
the management.
Yeah.
Data plane and one management.
Yeah, data plan and management plan, right? So in this data plan, we have three interfaces, right? 1/1, 1/2, and 1/3. So 1/1, this interface is connected to your router outside network, right? Okay. So let me just explain this thing. Let me just put it on this mode. Right. Okay. So we have zones here. We have different zones into our checkpoint. Sorry, Palo Alto. Okay. So we have different zones. Okay, remember one thing in the Palo Alto device, when you create any kind of policies, when you create any kind of rules into Palo Alto device, okay, so that rules you can create according to the zones, so that the rules applies to the zones only, not the interfaces. You can create a policy rules according to the zones. You need to put the zone into source and zone into destination, not any IP address or not any network address. Okay, so remember one thing, in the Palo Alto device, Palo Alto Firewall, the policy we create according to the zones. Okay, now, so we have 1/1, this interface. So this is connected to my router, to the ISP, right? And we have the external IP address here. You can say, this is my external IP address. So we have the one zone called outside. First zone called, we can say outside, or we can say external. So in the outside zone, we have the interface that is 1/1. Okay, now we have one more interface that is 1/2, and that is connected to my internal network, to my internal network users, local data connection of my users. Okay, so we have one more zone called inside. Inside. Okay, now this is connected. This has the including the interface that is 1/2, and we have one more interface that is 1/3, and this is what which zone, our DMZ, right? The public server DMZ zone. So we have one more zone that is called DMZ, and it has the interface 1/3. Okay, now suppose in the large organization, what happened? You won't have the any here in this diagram. We have only one internal network, 1/2. But in the large organization, what happened? You have different local area networks for the group of people, for the about the department size. Okay, so that might be possible in this inside network. You have more than one network interface. We can say 1/4, 1/5, like this way. So all these three interface included into an inside zone. Is all this interface included into an inside zone. Okay, and your outside, suppose if you have more than two ISPs. Right now in this diagram we have only one ISP. But if you have another ISP, so that also has one more interface that is called 1/6. Okay, and right now we have only one public server. And suppose if you have more than one public server, so you more be possible you have in the DMZ, you have more than one interface here. So how we wanna create a policy using the zones into a Palo Alto device? Remember this thing, guys. If you understand this concept, you can easily create a policy into a Palo Alto device. Now the next step is an important one. Let me change the color here. Now, suppose this is my user one, right? Now this user one wants to have access of the internet resources. Okay, so this user one included into which zone? This user one included
Inside.
inside this one, right? Okay, and
Yeah.
he wants to want to connect to the internet resources. So which zone he want to connect?
Outside.
Outside. This one, right? So this way, from 1/2 it will go to the 1/1 and to the ISP. So you will create a policy like this way, inside to outside. So inside becomes your inside zone becomes your source, and outside zone becomes your destination, right? Because user one is requesting for the Google services or internet sources, so that this becomes our source. A destination 1/1 outside network, right, guys? Understood this?
Yeah.
Understood this? So according to this,
Yeah.
you can create policy. So when you want to allow any kind of internet resources to allow this user, so you will need to put your inside zone as a source and outside zone as a destination. Okay, now suppose you have one more user here. Let me just change the color first. Not red one. Okay, suppose you have one more user here. We can say here Jack. You have one more user Jack. Okay, now who wants to access your this sub DMZ server? So how the packet flows? This Jack is from the outside network. This one. 112. So this
Outside to DMZ.
yes. So this is included into outside, right? And this will go to the DMZ. So it's DMZ, that is our third zone. So in this, the packet, the policy goes from this way, right? So outside becomes a source and DMZ becomes a destination. Understood this concept, guys? Zones?
Yes.
Everyone?
Yeah.
Any question you can ask me. Everyone understood?
What if
Yes.
what if different? So like for instance, if user one wants to access the ISP, so he has to go through two different policies, right? One for the inside and one for the outside.
No. This is the first policy. It has to go to one policy only.
Okay.
This is the my first.
So if the user is if the user is trying to access ISP, he will go through the inside policy.
Inside
If
zone
the
to
ISP
outside.
is trying to inside to outside. If the ISP is trying to access the user or the server, then he will go to outside to the
DMZ.
inside or outside.
Outside to DMZ.
Like that. So only one. So Anish, for example, if ISP wants to access the user like PC1,
not possible.
Okay. Not possible. Okay.
Because we don't want that anyone from outside network will access our internal network. We don't want that.
So those kind of policies will put it in outside or inside.
We are suppose in by default in Palo Alto device, each and every traffic is by default blocked.
Okay.
Palo Alto device, each and every traffic that is by default blocked. even the ping ICMP protocol also, the ping command. You cannot ping anything. If you want to ping your Palo Alto device, any of your interface, you want to first allow the ping service into your policy.
Oh, okay. Okay, okay.
By default, everything is blocked.
Oh, okay.
Okay, so whatever policy you want to allow, so that policy you have to create, that's it.
Okay.
And you don't want that from ISP side, suppose the JAX user, you don't want the JAX user can access our internal network, because in internal network we have our important data, right?
Yeah, yeah.
So we don't want that anyone can from outside network will access our internal network. That's why we create a DMZ, and DMZ we put our public servers, right? So understood this,
Okay.
everyone?
Yeah, yeah.
The outside policy is more strict than the inside policy.
Inside is more secure because we put our firewall, whether it is any firewall, Palo Alto, Checkpoint, any Cisco EC. We include the firewall into our network to prevent our internal network, not the outer network.
Right.
That's the reason we included the firewall into our network to prevent our internal network from the hackers, from the any kind of attacks,
Right.
from the viruses. Okay, so we discussed here today the management plan and data plan, then the interface development options. There are 5 options: layer 3, virtual wire, layer 2, and HA and TAP. Then we talk about the data plan routing tables, that is VR, virtual wire, virtual router. We talk about the zones. So everyone understood all these things? Hello?
Yes, Anish. Yes, Anish.
Sure?
We have to revise though. We'll
Yes, you
forget.
need to revise this. That's true. You cannot remember this
Yeah.
thing
Okay.
in the one session. You have to go through it once, twice, thrice. So that's the only reason I'm sending you one document today. Okay, now I have 2 questions in my mind. Can I ask you? Regarding this, what we have understood today. First question is,
Yes.
what is the name of the default virtual router in the Palo Alto device? The answer is a question only.
VR1.
No, that we created.
Palo Alto device itself.
No,
The
we are talking about the default virtual router. I already give you the hint. Your answer is in your question only, guys. The answer is default.
What?
Default. The
The
name
name
of
of the
the
virtual router is default?
yes, the name of the default virtual router is default.
Okay, okay.
That's why I told you the answer is in your question only.
So we change the default virtual router to VR1 or we just add one
We need to add.
VR1? Okay, okay.
Okay, and if you don't want to use the default one, we can remove that also. Okay, that we are going to see practically in our session, next session. Okay. Now, second question. Now, which interface development option allows routing and netting?
Hello?
Which
Layer
interface
3.
development option allows routing and net?
Layer 3.
Layer 3, right? That's true.
Yeah.
That's true.
Layer 3. What? Right.
So, this is all about